In this example, we have two vectors, a and b, and the question is, what is the sum, a plus b? Well, in graphically adding vectors, we have to realize that we can move vectors anywhere we want, as long as we don't change the magnitude, the length of the arrow, or the direction, the way the arrow is pointing. According to the rules of mathematics, what we want to do is we want to take the second vector and we want to move it until the beginning of the arrow, what we call the tail of the vector, is pointing at the tip of the arrowhead, what we call the head of the first vector. So let's do that now. We'll take the vector b and we'll move it until its tail is resting at the head of vector a. Now getting the answer is easy. All we have to do is draw a vector that starts at the tail of vector a and ends at the head of vector b. That's the vector sum of a plus b. Alright, now we're also supposed to draw the vector b plus a. Let me save the result of this part of the problem, and then let's move on to that problem. What's the sum of the vector b plus the vector a? Well, once again, we follow the same principle. We take the second vector, in this case a, and we move it until its tail rests at the head of b. Then we draw a vector that connects the tail of b to the head of a. That's the sum b plus a. Now let's compare our two results. Let's take the vector that represents a plus b and let's move it so that it sits next to the vector that represents b plus a. Notice that these two arrows have exactly the same length. That means the vectors have the same magnitude. Also, notice that they're pointing exactly the same way. That means the vectors have the same direction. Therefore, these two vectors are completely equivalent. So a plus b is the same as b plus a. So vector addition is commutative, just like scalar addition.